Okay, so the formulas and everything we will be discussing like in between the questions only. Okay, so let me take another question. If I feel that I need to explain more about the formula, like from where it came, how we got, I'll be explaining in between questions only. So the next question over here is a vessel is in form of a hollow hemisphere mounted by hollow cylinder the diameter of the hemisphere is 14 centimeter. Okay, and the total height of the vessel is 13 centimeter. Find the inner surface area of the vessel. Okay, just a second. Yes. So yeah, let's continue. We are having a vessel which is in the form of hollow hemisphere. Hollow hemisphere, okay? So like a bowl, this is a hollow hemisphere. Okay, a bowl kind of a structure is there, which you can see over here. Okay, a hollow hemisphere, or let me draw it properly. We are having a hollow hemisphere. Okay, a vessel is in form of hollow hemisphere mounted by a hollow cylinder. So on the top, okay, on this hemisphere, we are having a hollow cylinder. Okay, hemisphere is mounted by a cylinder like this. Okay, like this. The diameter of the hemisphere is 14 centimeter. Diameter of this hemisphere is given as a 14 centimeter. Okay, and the total height of the vessel. See the total height of this vessel. This one is given as 13 centimeter. Find the inner surface area of the vessel. We have to find the inner surface area, keeping in mind the cylinder is hollow and the hemisphere is also hollow. Okay. Let's think about it, how we'll be finding the total surface area of this vessel. Who will say what will be the total surface area of this container? Total, like the inner surface area. Let me write it properly. Inner surface area of this vessel will be,
Will be total surface area of surface area of hemisphere plus surface area of
yeah,
cylinder.
yes, it will be. Okay, it will be just the surface area of cylinder plus surface area of hemisphere. When we are saying surface area, we are talking about curved surface area. Okay, because both are hollow. Okay, so inner surface area of vessel will be curved surface area of the cylinder plus curved surface area of hemisphere. Okay, now we know the form. Can you tell me what is the formula for curved surface area of the cylinder?
2 pi RH.
2 pi RH. Okay, and what is the curved surface area of hemisphere?
2 pi
2 pi
r
R.
square.
2 pi r square. So we will be adding both of them. Okay, now for
Ma'am,
cylinder,
can't we just take 2 pi R as common?
yeah, we can take 2 pi r as a common because r is same for both cylinder as well as hemisphere. Radius is same. Okay, so yeah, we can take 2 pi r common, and in bracket we'll be having r plus h. Fine. Now, can you tell me what you will be taking as the height of this cylinder? Radius is clear that the diameter is given
13
with the help
minus
of the
7.
diameter. Yeah,
13 minus 7.
yeah, it will be 13 minus 7. Okay, because if diameter is 14, the radius will be 14 by 2, that means 7. This is also the radius. Okay, this is also radius. So we have to subtract this much from 13. Then only we will be getting the height of the cylinder. Okay, this much is 7 centimeter. If you will do the subtraction, you will be getting the height of the cylinder will become 13 minus 7. Everyone getting it? Yes.
Yes.
Okay, please do the simplification now. I am writing the another question. Radius diameter was given as a 14, and we found radius will be d by 2, that means 7. Okay,
So we'll use the height as 6.
yeah, we'll be using the height as a 6.
I got the answer.
Okay, tell me what are you getting?
I got 572 centimeter square.
Okay, everyone please check it. Are you getting the same? Just a moment.
9 572 centimeters square.
Okay, everyone is getting the same. Okay, so a cubical block we are having. A cube, basically cube we are having. A cube we are having, which is having side 5 centimeters. So side A is given as a 5 centimeter. Is surmounted by a hemisphere. So on this cube there is a hemisphere which has been placed like this. Okay. Now hemisphere fixed on the top has a diameter. Diameter of this hemisphere is given as 4.2 centimeter. We have to find the total surface area of this shape. Okay, total surface area of this shape we have to find. So yesterday I was telling you, whenever we will be finding surface area, total surface area, whatever, we will always think what are the surfaces which we can feel. Okay, keeping in mind these two objects which we can see different solids we are having, these two are pasted together. So there is a cube on the top of the cube, the hemispherical shape. It is pasted with the cube. Okay. Now we have to find the total surface area. So what are the surfaces which we will be filling? Think about it. We will, if we will find the total surface area of this cube, okay, in this cube all the surfaces are involved. Total surface area of the cube will be 6a square, right?
Yes.
Okay. Now we will take a pause and we will think. All the surfaces of this cube are involved. So yes, bottom one, side one, okay, the front and the back, and the top. The top one, there is a confusion, little bit of confusion we are having because here only this is pasted. Okay, the hemispherical shape is pasted on the top. So 6a square is fine. Now, can you see there is a hemisphere? So we will be taking what, the curve surface area. Can you tell me what are you thinking? Then I am coming to the explanation part.
We will take the surface area as the bottom part will not be included.
Okay, surface area of the bottom part of this cube shape will not be included, right?
Surface, the bottom part of the hemisphere will not be included, so we will take CSA, right?
Curve surface area will be taking, yeah, because it is pasted as I am saying. So curve
Hmm.
surface area will be taking. Are we done? 6a square plus
No,
curve surface
we
area.
can subtract the surface area of the sphere.
We have taken the surface area of cube, and then when we will try filling, then we can see a hemispherical shape is there. That also we are taking the curve surface area. Subtraction, what we will do? Think about it. Yes, we will do something subtraction, but think about it. What we will subtract?
Subtracting the surface area of the sphere, right?
sphere or this area of the circle?
Area.
Yes. When we will find the total surface area or surface area of the cube shape, we understand all the surfaces area are added together. But on the top, all the portions are involved, including a circular portion. Yes or no?
Yeah.
That circular portion, if we will try feeling, we cannot. If we will try painting, we cannot paint that circular part because the figure is pasted. Yes or no? So what we will find that we have painted the cube shaped boxes there. We have painted the bottom one. We have painted the side one. We have painted the back and the front one. But when we are going to paint the upper part of the cube shape, okay, upper part of the cube shape, we are just able to just paint the teeny tiny parts which are left around the corners. Yes or no?
Yeah.
मतलब कि जहां पे ये सर्कुलर पार्ट फिक्स्ड है बस उतना हम पेंट ही नहीं कर पा रहे हैं, उसको छोड़ के हमने सब कुछ पेंट कर दिया है क्यूब शेप में, राइट?
Yeah.
तो हमने क्या फील किया कि ये जो टॉय है या फिर जो भी शेप है, इसमें टोटल सरफेस एरिया ऑफ द क्यूब इन्वॉल्व है, बट जैसे ही हमने पेंट करने की कोशिश की, ये जो सर्कल वाला पार्ट क्यूब के जिस ये वाले अपर पार्ट पे जो फिक्स्ड है, इससे हम पेंट नहीं कर पा रहे थे। मतलब कि सर्कल का एरिया हमें सब्ट्रैक्ट करना होगा, सिर्फ सर्कल का। हेमीस्फेयर एंड ऑल सॉलिड के बारे में अभी हम सोच ही नहीं पा रहे हैं, क्योंकि जो हेमीस्फेयर का बॉटम है वो तो एक सर्कल है, वो तो जस्ट एक सर्कल है, राइट?
Yeah.
So from here we will be subtracting the area of the circle. Okay, 2D शेप जो हमारे पास सर्कल है, जो हेमीस्फेयर का बॉटम है, बस वो हम सब्ट्रैक्ट कर रहे हैं क्योंकि
But
उससे
it's
हम
not
पेंट
really
नहीं
a
कर पा
circle,
रहे।
right?
यस,
It's not really circle, it's a sphere.
इट्स अ स्फीयर, बट क्या हमें पता है कि स्फीयर का ये जो ओपनिंग होता है ये एक सर्कुलर शेप होता है?
Yeah.
तो यही तो फिक्स है।
Oh, okay.
ओके, ये तो एक हेमीस्फीयर ही है। ओके, 3D शेप है ये। देन व्हाई आई एम सेइंग सर्कल? क्योंकि ये जो स्फीयर का ये जो एक बाउल को अगर हम बैठ के देखें तो हमें दिखेगा ना कि ऊपर वाला अगर एक लिड से कवर करने जाए तो हमें सर्कुलर लिड चाहिए होगा कवर करने के लिए, राइट? तो दैट्स व्हाई वी आर डूइंग द सब्ट्रैक्शन ऑफ पाई आर स्क्वायर, कि ये जो सर्कुलर पोर्शन है ना, इतना हम कलर नहीं कर पा रहे हैं, बाकी सारे पोर्शंस को हम कलर कर पा रहे हैं। कहाँ पे? लेट मी शो इट टू यू। we will be able to color, this part. Just keep your eyes on the cursor. Okay, this part, this, the back one, okay, here. But the circle, okay, the circular part we will not be able to cover. उसके बाद जब हम फील करने की कोशिश करेंगे तो हमें समझ में आएगा एक कर्व पार्ट भी है, हेमीस्फेयर का कर्व पार्ट भी इन्वॉल्व है इस टॉय में, तो इसका भी एरिया हमें लेना पड़ेगा। एम आई मेकिंग सेंस?
Yeah.
Everyone, are you getting it? That's why I am telling that whenever two shapes are just attached together, pasted together, combined together, हम हमेशा यही फील करने वाले। सो ऐसे ही समझेंगे कि हम कौन कौन से सर्फेसेस को फील कर पा रहे हैं, वो सारे ही सर्फेसेस का एरिया हमें फाइंड करना होगा यहाँ पे। Everyone, is it making sense to you?
Yes.
Yeah.
Yes.
Okay, so basically for total surface area of this solid, for total surface area of this shape, what we will do, we will take the total surface area of the cube minus circle's area plus curve surface area of this hemisphere. Curve surface area of this hemisphere. Now here only I want to tell you few more things. Please pay attention. So ये जो हमारा शेप होता है ना, स्फेयर, हेमीस्फेयर, यू शुड नो कि जब मैंने एक स्फेयर को ड्रॉ कर दिया इस स्क्रीन पे, practically it is not possible for me to draw properly a 3D shape and show it to you, but we will be in real life so many hemisphere shape we are having. Football, globe, or oranges, these are the hemispherical shape. इसमें जब भी हमारे पास, सॉरी आई एम सेइंग हेमिस्फीयर, स्फीयर, ओके, सो whenever we are talking about spherical shape, इसमें सिर्फ एरिया होता है, एक ही एरिया, स्फीयर में सिर्फ एक ही एरिया होता है जिसे हम कहते हैं, या तो उसे कर्व सरफेस एरिया बोल लो या फिर टोटल सरफेस एरिया बोल लो। स्फीयर के अंदर सिर्फ एक ही एरिया होता है और उसका फॉर्मूला ही होता है 4 पाई r स्क्वायर, राइट।
Yeah.
बट अगर हमने इस स्फीयर को कट कर दिया, इट विल बिकम हेमी स्फीयर। अब इसके अंदर दो एरियाज हो जाते हैं, एक ये कर्व कर्व सरफेस एरिया, और ये जो सर्कुलर पार्ट है इसका एरिया भी इसका एरिया भी हम कंसिडर करते हैं। क्यों? क्योंकि हम ये सोचते हैं कि क्या पता ये कवर्ड है ऐसे किसी लिड से, सर्कुलर लिड से, ओके। तब जाके हेमीस्फीयर में ये दो कंसेप्ट्स आते हैं कि हेमीस्फीयर हैज कर्व सरफेस एरिया जो कि हाफ होता है स्फीयर के एरिया के, दैट इज 2 पाई r स्क्वायर। एंड हेमीस्फीयर में टोटल सरफेस एरिया भी होता है। टोटल सरफेस एरिया का मतलब क्या है? ये जो कर्व सरफेस एरिया है वो, और एंड जो सर्कुलर लिड, हम अज्यूम कर रहे हैं कि ये जो टॉप है ये सर्कुलर लिड से कवर भी तो हो सकता है, तो इसका एरिया भी हम अज्यूम करते हैं, दैट इज πr²। और ये जो एरिया कर्व सरफेस वाला है 2 पाई r², तब जाके हमें यहाँ पे टोटल सरफेस एरिया मिलता है हेमी स्फीयर का, दैट इज 2 पाई r² प्लस πr², जिससे हम डायरेक्टली 3 पाई r² भी लिखते हैं। आर यू गेटिंग इट?
Yes.
Yeah.
और जब भी हम स्फीयर की बात करते हैं तो रेडियस का मतलब क्या होता है? ध्यान से सोचो, थोड़ा सा विजुअलाइज कर लेते हैं कि अगर हमारे पास एक फुटबॉल है तो हमारे माइंड में ये होना चाहिए कि उसके अंदर कहीं पे एक हवा में कोई एक ऐसा पॉइंट है, ठीक है, जिससे स्फीयर के ऊपर ये डिस्टेंस, ये डिस्टेंस, ये डिस्टेंस, ये डिस्टेंस, ये सारे ही डिस्टेंस सेम होंगे और उसे ही सेंटर बोलते होंगे स्फीयर का। और ये सारे जो डिस्टेंसेस सेम आ रहे हैं इसे हम रेडियस कहते हैं, क्योंकि सर्कल को तो हम देख पाते हैं लेकिन स्फीयर के अंदर हम अच्छे से विजुअलाइज नहीं कर पाते। तो ऐसे हम समझ के रखेंगे कि स्फीयर में रेडियस का मतलब क्या होता है कि अंदर जो हमारे पास फुटबॉल है उसके अंदर कहीं पे एक पॉइंट होगा, फुटबॉल के ऊपर नहीं, उसके अंदर कहीं पे हवा में कोई एक ऐसा पॉइंट है जहां से फुटबॉल के ऊपर जितने भी डिस्टेंसेस हम लेंगे ये सारे ही सेम होंगे, उसे ही हम रेडियस बोलते हैं। गेटिंग इट?
Yeah.
जस्ट अ सेकेंड। Yes. So if you have understood the previous question, please do solve it, no? This one. I'm sharing it, just a moment.
Ma'am,
Hmm?
I'm getting 163.86 centimeters square.
163. Okay. Yes. Yes, this is the answer. Everyone getting the same.
Yes.
Okay. Yes, Ibad, are you getting the same?
Yes, ma'am.
Okay. So let's do the next question. Read it carefully and you are going to tell me how we'll be finding the area over here, whatever is asked over here. So a hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L of the hemisphere is equal to h of the cube. Determine the surface area of the remaining solid. Okay, a hemispherical depression is cut out. Just a second. Okay, okay, a hemispherical depression is cut out from one face of cubical wooden block. Depression means we understand the depression like this will be there, which we were discussing in last class as well. So we are having a cube shape at first.
Radius will
And
be A by 2, right?
yes, okay. So a hemispherical depression is cut out. So basically now our figure looks like this. Like this. Okay. This type of hemispherical depression is cut out from wooden block. This is a cubical wooden block. At first we are having a cube shaped wooden block. From one of the face we are cutting a bowl type of structure. Okay. Such that the diameter L of the hemisphere, diameter L of this hemisphere is equal to edge of the cube. Okay. So if you are saying that edge is A, so diameter L will be equals to A. So of course, radius will be A by 2. Okay. Determine the surface area of the remaining solid. You are going to tell me what will be the surface area of this remaining solid? Means once we are cutting it, then whatever we are having in hand, the solid, whatever way it looks like, that solid's surface area, what will be the surface area? Think about it, what
So
you will be able
surface
to.
area of cube minus surface area of hemisphere.
Yes, everyone.
Ma'am,
Yes.
will it be surface area of sorry TSA of cube plus the hemisphere CSA of hemisphere minus the base,
Yes, it will be.
like the question we did last time,
Yeah.
the previous one?
Yes, it will be. Okay, why it will be remaining, the this remaining, what will be the surface area of the remaining solid? This terminology must not confuse you. Think about it. We are having a wooden block, a cube shaped wooden block we are having. If I'll give you a cube shaped wooden block and I will ask you find the surface area, you will be finding the total surface area, okay, of the cube. But now in this wooden block, I am cutting the upward portion, one of the face, maybe the top face. I am cutting it and making it a bowl type of a structure. Okay, with whatever be the depression, radius and all relation given over here. So I am making a bowl type of a structure from the top. So what you will think now? Now in this wooden block, everything is present. Okay, the like all the faces are as it is, only I have disturbed the top face, right? Yes, so only I have disturbed the top face. We are talking about the surface area, we are not talking about the volume. So even if its volume is decreasing or what, we don't have to go in that direction. We will be only thinking about area of all the surfaces added together, that is called the total surface area. Now all the surfaces are present in the cube except the top face. Now if you will try feeling what is there in the top face, so you will realize that a circular structure I have cut it from the top face. Okay, to make a hemisphere, I have cut it like a circular structure. So that face, the top face, from the top face, what is missing? A circle structure is missing, right? And then if you will try feeling, can I say, if you will try feeling with the help of your finger, you will be able to feel a hemisphere over there. Yes or no?
Yes.
So now what is the total surface area of this shape which we are having in hand? So we felt that we'll be finding the total surface area of cube, but there a circular portion is missing. From one of the face, a circular portion is missing. And then we have also felt that there is a hemispherical shape, only the curved surface area of hemispherical shape. Everyone, is it clear now?
Yes.
Yeah.
Okay,
Yes.
so the terminologies will be like this. What is the remaining? And we will feel that from a cube, hemisphere is missing. So that will be, the remaining will be cube minus hemisphere. But no, try to think it this way. Visualize the shape and try feeling that what are the shapes you will be able to feel once we are cutting it like this and all. Okay, so find it. Yes, Ibad, are you getting it?
Ma'am,
Yes,
do we have
ma'am.
to substitute the pi?
Here, are you getting answer in terms of A or L? L, right?
I haven't calculated it.
Try using L over here, okay? Because L is mentioned in the question, no? So A also will be using in terms of L, क्योंकि question में L एक वेरिएबल ऐसा ऑलरेडी दिया हुआ है, तो हम जो ये क्यूब का एरिया फाइंड करेंगे उसे भी हम L के टर्म्स में ही रखेंगे, क्योंकि क्वेश्चन में L मेंशन्ड है. हमारा जो फाइनल आंसर होगा उसमें पाई को एज इट इज रहने देंगे, एल को एल रहने देंगे, और एंड मे बी आवर आंसर विल बी इन टर्म्स ऑफ एल एंड पाई. टेल मी.
Are we taking A as L by 2?
In the question, it was written that, just a second. No?
So if like the diameter is L, then the radius would be half of that, right?
It says that diameter, wait, the
Ma'am, can
diameter L of the hemisphere is equals to the edge. So our edge is L, right? And radius will be L by 2. That's it. Each side of cube is L and radius will be L by 2 because the diameter is L, right?
Yeah.
Okay. So yeah, we need to take it like this.
So A will equal L.
Yeah, the side is L.
ma'am, can you solve that question?
Yeah. So 6a square means 6l square minus pi r square. So pi I am keeping as it is because anyhow we are going to get our answer in terms of L. So pi ke place pe 22 by 7, like even if we will be putting, we'll not be able to do that much of simplification over here. I am keeping pi as it is. You can also keep in such question which will be where the answer will already, the answer will be in terms of L, P, M, N. You can keep pi as it is. So r square is L by 2 whole square plus curve surface area of the hemisphere, that means 2 pi r square. Okay, r is again L by 2 whole square. So it is 6l square minus pi into L square by 4 plus 2 pi into L square by 4. Okay.
Ma'am, can you cancel the 2 and 4?
Yeah, sure. I can cancel 2 with 4 like this. Okay. Or I can keep 4 as a 4 only because I want to take this pi with pi at first. Okay. I want to combine this pi with pi. And if the denominator is already same, I don't want to disturb it. You should also don't disturb. Denominator is already same. You are basically having 2 pi L square by 4 minus pi L square by 4. That means 4 is the LCM. 2 pi L square minus pi L square. It looks like 2x minus x. So the answer will be only x. Am I making sense? Yes or no? Can
Ma'am,
we write
I
it as like
substituted the
this?
pi
Yeah.
and I
I
got
cancelled it and then I took the LCM.
6.78 L square.
Okay, no worries. Okay, even if you are canceling it, okay, you can keep it like this. We got this one. Okay, and 6l square is as it is like this. Now we can take the LCM like this. Okay, we'll be having 6 4 times 24 L square minus pi L square. So basically in our answer L square is common, by 4 is common, and 24 minus pi is there. If we will take now pi value as a 22 by 7, because pi is a number, 24 is a number. Let me check, am I missing anything? No. So yeah, now it looks like even if we will be taking the value of pi as a 22/7, little bit of simplification we'll be able to do. Okay, more simplification. Because 24 minus pi is there. Pi is the number, 24 is a number. So why not? Let's do the simplification. So
Ma'am, I
24 minus 22/7.
6.78 L square.
L square by 4. This is what we have got so far. Okay, we will be having L square by 4 and 24 into 7, 168 minus 22/7. Now our answer will be, we cannot do much from here. 168 minus 22 is 4. Okay, 8 minus 2 is 4. 6 minus 2 is, wait, 8 minus 2 is 6. Then 4. Then 1. 146/7. I can see we can cancel them. So 4, 3 times 12. No, with 4 it is not possible. With 2 it is possible. 2, 7 times. Okay. Yeah. We are getting L square 73 L square by 14. Can you see everyone?
Yes.
Yeah. Again, I'm telling you, please check the simplification. The numbers, okay, you have to check it, the multiplication and all, is it like correct or what? Okay, this is how you can do the simplification. Is it clear?
Yeah.
Now, I'm going to give you the hint of this question which I have written over here so that you can try it at home. So this question, let me tell you the number, which question number we are having. Just a second. Question number 8. Okay, question number 8. It is exactly like the previous question, which we are solving previous last 2 to 3 question the way we have solved. From a cylinder of height 2 point, we are having a cylinder. The height of this cylinder is given as a 2.4 centimeter. Diameter is given. Okay, diameter is given as a 1.4 centimeter. A conical cavity of same height and the same diameter is hollowed out from this solid cylinder. Whenever in the question it says that solid block, solid cylinder, try thinking it as a वुडन ब्लॉक लाइक अगर मैं बोल रही हूँ हमारे पास एक क्यूबिकल सॉलिड क्यूबिकल शेप है, मतलब कि वो अंदर से हॉलो नहीं है, ऐसा हम सोचेंगे. ओके, जैसे कि वुडन ब्लॉक होता है. अगर ये जो सिलेंडर है हमारे पास, ये सॉलिड सिलेंडर है, मतलब कि हॉलो नहीं है, अंदर से हॉलो नहीं है, ये इट कैन बी इन द शेप ऑफ वुडन ब्लॉक. ओके, विच इज नॉट हॉलो. यहां से हम क्या कट कर रहे हैं, एक कॉनिकल कैविटी कट कर रहे हैं, ऐसे कुछ ऐसे. ओके, ये जो सिलेंडर का डायमीटर है, सेम डायमीटर मेंटेन करके एक कॉनिकल कैविटी हम कट कर रहे हैं. और यहाँ पे भी हमें क्या फाइंड करना है, अब जब कट हमने कर लिया तो जो रिमेनिंग सॉलिड हमें बचा हमारे पास, उसका सरफेस एरिया हमें फाइंड करना है. तो हम ध्यान रखेंगे कि यहाँ पे भी हम सिलेंडर के एरिया से कोन का एरिया सब्ट्रैक्ट नहीं करेंगे. यहाँ अब हम दो शेप्स कर पाएंगे, सिलेंडर भी और कोन भी. ओके, and accordingly we will be taking both the area and then we will be finding the total area of the obtained shape. Am I making sense?
Yes.
Okay,